All right, let's go ahead and get started. Welcome to the July 2021 Phoenix Lidar Systems webinar. Our host today is our senior geomatics engineer, Corey Kellum. Go ahead, Corey. Why don't you go ahead and start with your introduction?
Thank you, Lito. Yeah, hello and welcome everyone to another installment of Phoenix Lidar Systems webinar series. I'd like to start by thanking you all for taking the time out of your busy schedules to end our panelist discussion today on aerial survey with high performance LiDAR. So as Lito mentioned, my name is Corey Kellum. I'm the lead geomatics engineer at Phoenix Lidar Systems. And I'm excited to host another application-specific webinar to provide an inside look at how surveyors and engineers leverage LiDAR technology in real-world mapping and design projects. So before we dive into a discussion with our distinguished guests, allow me to take a brief moment to explain who we are and what we do here at Phoenix. So Phoenix Lidar Systems is an industry leader in commercial UAV LiDAR integration and a true innovator in the space. Rather than sell products, our team designs and builds purpose-built solutions configured to our customers' exact specifications to ensure a perfect fit for application, performance, and capability. And we are based out of Austin, Texas, and we are proud to be an American company with a global customer base, serving and supporting hundreds of clients across 40 different countries. Our mission is to build complete LiDAR mapping solutions crafted with quality hardware, innovative, intuitive software, and vehicle flexibility in mind to deliver survey-friendly solutions, enabling users to offer faster, safer, and more economical service options without compromise. In order to accomplish this mission, Phoenix has paved the way by being the first company to offer a commercial UAV LiDAR system while simultaneously providing the first real-time 3D point cloud visualization software. Phoenix also developed the first UAV LiDAR terrain following flight planner, along with the first cloud-based automated LiDAR post-processing platform, LiDAR. So UAV-based LiDAR has transformed the surveying industry by offering large area mapping at scale. And in this webinar, we will explore the process, strengths, and limitations of aerial surveying with high-performance LiDAR. Throughout this webinar, we'll learn from the real-world experiences of Pape-Dawson Engineers as they review their decisions and experiences from launching a successful aerial LiDAR program. We will begin the webinar by introducing the panelists and get more familiar with Pape-Dawson Engineers. Then we will move on to a discussion where we'll take a look at the benefits and limitations of LiDAR with some examples of successful real-world projects. And we will save some time at the end to answer questions from our attendees. So if you think of a specific question, feel free to type it into the chat during the presentation, and we will get to that at the end. So let's start by getting to know the geospatial team members at Pape-Dawson Engineers. Today, I'm joined by two highly experienced geospatial experts leading the Pape-Dawson LiDAR team, Angela Livingston and David Trotter. Angela and David, thank you so much for being here. Please give us a little background about yourself and the Pape-Dawson team.
Thanks, Corey. Really happy to be here and share our experiences with everybody that we've learned over the years. I'm Angela Livingston. I'm the practice leader of our geospatial services team here at Pape-Dawson. I'm a certified photogrammetrist, a certified LiDAR scientist, and a GISP, and also a Part 107 pilot. I've been using LiDAR since the early 2000s in the manned aircraft world, and then through my career I've moved up through different companies, and now I'm here at Pape-Dawson. We integrated this UAV LiDAR program in 2017. Joined by David Trotter, who is our lead processor and chief pilot. He's flown thousands of hours of flight time. He's helped develop all of our workflows and processes, which we're constantly tweaking. But he's here to answer questions as well as about our, how we go about our workflows and handle our projects on a day-to-day basis. So Pape-Dawson is headquartered in San Antonio. We've been here since 1965, and we've grown to have offices in Austin, which is where Dave and I are at, Houston, Fort Worth, Dallas, and New Braunfels. We are now up over 700 employees. Our main services are civil engineering, surveying, GIS, and environmental services for land development, transportation, and water resources, where our clients consist of both public and private entities. 5 of our 7 offices have survey departments. In San Antonio alone, we have 16 field crews. In Austin, we have 4, Dallas 2, Houston 3. And our geospatial team consists of basically 4 people, and we support all of these offices with the same 4 people. So we can cover a lot of ground with little staff, basically.
That's great.
Yeah.
Yeah, thank you for that background. Now that we have a better understanding of your team's background, let's take a look at your specific LiDAR system. And I'm curious, which Phoenix Lidar system do you operate, and which platforms do you typically mount this system on when you're traveling around the state of Texas, mapping all these different sites?
So our Phoenix system is the Ranger, the VUX-1 UAV. And we started out with an M600, and we also fly a Harris H6, which we recently got a couple months ago. We're still implementing that and tweaking some things with that, but our main workhorse is the M600. We do have another scanner that we purchased. Our first scanner in 2017 was a Velodyne 32 from another company. So we run both of those, but we upgraded the end of 2020 to the VUX-1 just for the accuracy that it and the cleanliness of the point cloud that it creates has really proved to be beneficial. Again, we still use both systems. It just depends on the environment, which one we choose to use on what project.
Okay. Yeah, upgraded to the UAV to just get that crisper ground profile.
Yeah, the UAV, the flight time alone. So what we were seeing with the M600 was, especially with the VUX-1 scanner, we were looking at 10-minute flight times, and with the Harris, we're 45 to 60 minutes or so on that platform. So it really helps. It helps our efficiency a lot. We can fly with the VUX-1. We can fly higher as compared to a Velodyne, where you're stuck at like 150 feet. So it's helping us cover more ground for sure.
You typically fly at that 400-foot ceiling?
Typically about 300.
About 300 feet.
Yeah. But we could do 400. Just depends on the point density we're trying to achieve.
Right. Great. So yeah, let's discuss the benefits of LiDAR. So I know that surveyors use total stations, digital levels. You guys do RTK surveying for conventional topographic mapping. How does this type of data, the conventional topographic data or the methods that you use, compare to data collected using an aerial LiDAR system? And I'm also curious, what are some of the benefits to using an aerial LiDAR system, and what are some of the best applications that are surveying engineering specific?
Yeah. So most of the LiDAR work we do is strictly existing conditions, topographic surveys. And when we first started collecting data, we went back and we compared our typical conventional on the ground work. We would collect a 50-foot grid or 100-foot grid, depending on the site. And with LiDAR, we're getting points every few inches. And so just the amount of detail that we get has really proved to be probably the most beneficial. So we went through and we compared the resolution of the LiDAR compared to those different grid intervals, which we have these slides to show. So this is a full resolution of a LiDAR point cloud. And if we decimate that to a 10-foot grid, you can see, the ground become more clear. And then when we go to a 25-foot grid, you can see, we can still see kind of the profile of the ground. And then when we get to 50 and 100, you just lose that detail there on the edge. So this comes into play a lot when we do quantity calculations, dirt quantities, volumes, and things like that. When they do mass grading on sites, we will oftentimes get called out to verify the quantities. A contractor may have different answers than we do because they're not using LiDAR. They're using a truck with the GPS on the back of it, and they may miss some of the terrain features. So I think every cubic yard of dirt is money. So it's good to have this amount of detail for that purpose alone. Speed is another big benefit. We can, collect 500-600 acres a day, where it would take them weeks to do that on the ground. The vegetation penetration, so there may be some really difficult areas. It would take a surveyor, several days to cut line to get through it. We can just fly it and collect all the data. Access to sites is another big benefit, is that, we can go places and maybe aren't that safe, and just fly it. Maybe we don't have right of entry in all the places that we fly. So that's another big benefit. And then this slide here is showing the detail comparison from contours. You can see on the left side in conventional, the contours kind of cut through that road. We flew it with LiDAR, and you can see the detail there on that roadway.
Yeah, you can see the slope of the road in the contours with the LiDAR, but yeah, you definitely can't see that with the conventional. On the conventional, what was this, a 10-foot grid?
I believe that was 100-foot.
100-foot grid?
Yeah.
Okay. So instead of 1 point every 100 feet, you're getting 100 points every foot.
Yeah. So yeah, the big benefits for us have been really just the existing conditions, collecting all the data at once, and then mining the data later should they come back and say, oh, I need more detail on this roadway, or we can pick up power lines, things like that. We can always extract data from the same data set without having to go back.
Right, like with this data set, if they collected ground shots every 10 feet, you might have some contours, but they're looking for, any information about the vegetation around the road. They wouldn't have that, and you'd have to go back and survey it. But
right, yeah,
you already have all that information. Collect once and use many times, right?
Yes, all the time.
Yeah. So tell me about this mapping project. It looks like a railroad bridge. Yeah,
so on this job, super vegetated, and the engineers wanted the drainage that comes. There's actually a railroad bridge here, and we were flying the site to the south of it. Getting access on railroad right-of-ways is pretty difficult, and we just needed the base of the columns of the bridge and the creek bed there. So we flew this one a little lower, and we're able to model this bridge without sending somebody down in there. This, it would have taken them days to cut line to and set all the control to get this same information, and we already had it as part of the flight.
Yeah, that's great. It sounds pretty invasive too, to like the job site to be cutting line just to do a conventional survey, right?
Yeah, for sure.
Yeah. And then like on this particular project, it looks so vegetated. Will you be able to get like a RTK, like decent accuracy from?
Yeah, GPS wouldn't have worked here.
So yeah, that line of sight with the total station and all the different setups, just to get a fraction of the points that you're getting here.
Yeah.
Yeah, that's great. And I see that you have another project here. This is a river mapping project.
Yeah, this is about 2 miles of river bank. For this job, they were just interested in the top of the bank. And because it was so wide and vegetated, it would have taken days, maybe weeks to cut line and move around and try to find out where the top of the bank was. Where we flew this, and even got the bottom of the river and the other side that they didn't really need, but we got it, within 30 minutes or so. I don't know how long it took to fly this, but
yeah, about 45 minutes to fly.
Yeah.
45 minutes for a 2-mile section of river.
Right.
Yeah.
Wow, that is impressive.
And I can say, as someone who was on site for this, you couldn't approach that bank on foot without machete and some pretty serious equipment,
Mhm.
let alone a truck or anything like that. So I can't even accurately estimate how long it would take to even get to the bank, let alone get shots on it.
Absolutely. So this was like 45 minutes of data collection. What was like the processing time that it took to process this data and get it into like AutoCAD Civil 3D or whichever software that you were using to make a model or to do your design work?
Maybe total like 2 days.
Wow.
When you consider, that we have other jobs that we're doing simultaneously and stuff like that. But I think 2 days is a pretty good estimate.
Wow. So like a couple day turnaround for a 2-mile project. That's really impressive.
Yeah.
And yeah, tell me a little bit about this project. I see a colorized point cloud on the left and
Right.
the train model on the right.
Yeah, so it's just a typical Pape-Dawson project where it's land development. And this is just showing, the colorized point cloud. And then after we strip off the vegetation and process just a bare ground, just the amount of detail that you can see in the terraces and that the creek bed and the final DTM. I like this exhibit because when you first look at the ground, like the colorized point cloud, you can't tell that those features are there. So it's just showing the amount of resolution that we can get with the LiDAR.
Yeah, it's like is there a decent amount of elevation change at the river's edge?
Yes, there is.
Yeah, it looks like there's some steep banks there. That would be difficult to survey for sure. What's over there on the right side? Is that like a vineyard or like those terraces?
No, I think that's
They're
just
terraces in the.
Yeah, they're just terraces for the field.
So when you collect LiDAR and you go to make data products and you go to make engineering design models, what are like the data products that you're extracting from your LiDAR data? And what are the most valuable products that you've derived?
Contours basically. We will collect infrastructure. A lot of times, any improvements that can help save time with Category 1A surveys, things like that, we can get with either topo or LiDAR or photogrammetry. Sometimes they're interested in the tree canopies. Sometimes we can get tree trunks. We're still working on that workflow, but I think just having that data that we can go back and, maybe an engineer didn't tell us that they needed 100 foot outside of, the site that we flew. We always overfly a little bit than what they need so that we can go back and extract more data for them. So I think that that's the most valuable product is the point cloud itself.
Yeah. And that's a great idea, is just like spending an extra, 5 to 15 minutes of airtime while you're already out there.
It really doesn't add anything,
Yeah.
It saves a lot of money than going back and getting another 10 acres or so.
Have you had that experience before where they're like, oh, we want, an extra or this additional information that we didn't want? And you would say like, yeah, we can have that to you tomorrow, and then just charge them.
Yes, absolutely.
Yeah.
Not only additional ground, but often we'll get requests for additional detail on something that maybe they didn't know was out there, or something they didn't see in the first place. Like it'll happen quite often that maybe there will be drainage features or structures that are so buried in vegetation that maybe you wouldn't even know existed if you were out there on the ground. But we can see that through the trees, through the brush, through whatever. And if something turns out to be important, then like you said, like the next day, we can go in and, shed some more light on whatever that feature may be and produce, that product the next day based off of the same point cloud without having to mobilize anybody to get them in the field. you know, to say nothing of scheduling and weather and all the other stuff that, you know, kind of piles on. Yeah, the wealth of data in the original point cloud, no matter what you're pulling from it, is definitely, I would say, our greatest source of value.
Mhm.
So tell me a little bit more about this project. This looks really interesting. You have a BIM model of the bridge, and I see that you combine terrestrial LiDAR, mobile LiDAR, and conventional methods. Tell me a little bit more about that, about your setups and how you
Okay.
able to.
Yeah, this one was one of those projects where we kind of had to throw everything at it to get the end product. So we did mobile LiDAR for the top of the bridge. This river was about 200 feet wide, and they were expanding the bridge, adding lanes to it. So they wanted an accurate model of the existing structure. So we did terrestrial LiDAR underneath the bridge on each side of the river, and combined those with the mobile, and then we did some conventional to tie everything to. And then Dave took all this data in the microstation and created the 3D model of the vents and bends and all the columns and things like that. So it's just an example of, you know, one tool isn't always the answer. We could have used a drone probably over it, but for the accuracy needed for a DOT project, mobile LiDAR was the way to go. So.
And so you were able to just take your existing payload that you had mounted on a UAV and just swap it over to a car mount and drive it.
Yeah, that's a great thing about these scanners being so small and light, is, you know, you can mount them on anything. We don't do a whole lot of mobile mapping, but you know we have that option if we need to.
Right. Yeah, this is a perfect use case. Maybe you couldn't fly over the road.
Right.
Lots.
Yeah, and this bridge was really narrow. There wasn't any shoulder, so it was, to get it conventionally, we would have had to shut down lanes, and that's expensive to get traffic control for our survey crews. So we set control points on each side of the bridge in the roadway, in the shoulders that we could, and then drove it and tied it to that. So it wouldn't have been safe to have a crew walking around on this bridge.
Right. How automated was that feature extraction process, and which specific software did you use? Was it just MicroStation or was it TopoDot?
We just use MicroStation for this, and the process for this sort of stuff wasn't terribly automated, although we've been exploring some of particularly TopoDot's bridge features, and they do have some really handy automated features for stuff like this as well. On this, it was pretty hands-on. It's still, although another thing to consider with this project specifically is that we intentionally went a little bit overkill in terms of the accuracy that we needed, because we just wanted to see basically how much we could possibly get out of the single data set. So there's all kinds of details in there that a lot of automated features aren't necessarily built to pick up that this one can. Like, for instance, you can see all of those columns, you know, are measured multiple places all the way up the column, not just the location at the base. You can see which direction they're leaning, if their dimensions change as they go up. Along with the I-beams, they're measured, you know, every couple feet. Every single thing on that bridge is, you know, within an inch of real life conditions.
So when we processed this, we used a Leica terrestrial scanner and Cyclone to do all the point cloud registration, and then we also used TerraScan or TerraSolid products to process our aerial and mobile LiDAR. So basically, each software spit out a point cloud, and we merged them together.
Nice. That's a great use of data fusion.
Mm-hmm.
So we've talked about a lot of benefits of LiDAR. When you've been in the field, have there ever been any projects where you've noticed some limitations to LiDAR? And if so, how have you coped with those limitations?
Yeah, definitely. Ground cover is the biggest thing. We've been getting tons of rain here in Texas this year, and thick, matted, overlaid grass is really a problem. I don't think very many LiDAR sensors would even get through this. You know, the general rule of LiDAR is anywhere light can go, so can LiDAR. But in situations like this, so a little bit about our control workflow and what we do. We typically set panels every 1,500 to 2,000 feet across a site, and then we will collect check shots throughout the site, depending on the land cover type. But we minimally do 20 up to, it just varies on how big the site is. And we set nails where our check shots are and take pictures of each one of those so that we can see the surrounding ground cover to know when we're looking at the LiDAR data, what are we really in? Is it really vegetated, or is it, you know, maybe short grass? So in this situation, this was a check shot. You can see, you know, where our surveyors drove around or walked around the site and kind of laid down that grass around that point. And but you know, you go 10 feet out and you've got this super tall grass, and we can see that in the LiDAR data. You can see where they drove on the left side. That red dot is the checkpoint itself. And our ground penetration is dead on that check shot. But then again, next to it, we don't have any points on the ground. They're mostly on top of the grass. So what we try to do is kind of scout out the site before we even go to know what we're dealing with. And then we add some time and budget in there to supplement it with conventional on the ground. So we'll send a crew out and they'll get those 50 to 100 foot shots, or, you know, whatever density that we need. And we'll, you know, if the site's got a mixture of land cover, then we'll delete out, you know, like this tall grass area. This was a small pasture. We'll remove that information and merge it with the conventional topo to make one surface. So survey crews are not, you know, eliminated completely, obviously, but we do what we have to do to meet the accuracy that we promise.
I think this is really important to talk about, like assessing your site ahead of time and planning for that. And that'll help you have a more accurate quote, right? Because if you're like, you recognize that ahead of time and know that you have to conventionally survey a portion of it.
And it's important to have enough check shots in, you know, under the trees, in the thick grass, on pavement, hard surfaces, so you get that variety to get a more clear picture of what is going on the site. If you just did a cross section across, you know, each direction, you're going to miss some of these areas and think your data is accurate, and it's not.
Right. It's so important to take those, you know, hard surface ground control shots on roads or hard dirt, something like that. But then also, like you're saying, take those a variety of land cover check shots just to verify accuracy. And yeah, matted grass is a huge, it is a limitation that obviously you've found. In the Pacific Northwest where I live, it's blackberry bushes, and they're LiDAR's nemesis as well. They're just so thick that no light can penetrate it. And I think a good thing to mention here is that with your LiDAR scanner, you have one of the highest precision LiDAR scanners on the market, if not the highest, and it has like a 0.5 millirad beam divergence, and it still couldn't, you know, penetrate get accurate returns to this grass. So really no LiDAR is going to do that.
Exactly.
So I know a huge question that a lot of surveyors that might be listening in, attending this webinar, are curious about, if they don't already have LiDAR, is, okay, so now you have a LiDAR point cloud. That's great, but how do surveyors and engineers effectively use this data in their current workflows? How do they implement that? And can you summarize your typical workflow from mission planning to product delivery to give us a better idea of what that looks like?
Sure, I can take that. So the first thing we do, kind of to circle back to what we just mentioned, the first step is site assessment, right? Is making sure that this is site that that does make sense for LiDAR. The size or ground conditions or any number of factors. But once you're there, the first step is to send a crew out to set control and your ground check shots, as we just discussed, that cover kind of a variety of ground surfaces, no matter what's out there. Next, once the control's down, the panel's down, then you just go out and fly it. Usually pretty quick and straightforward, the collection itself. A vast majority of our time is spent after data collection is on the processing side. After that, we will take the trajectory generated by the IMU and we'll run it through Inertial Explorer to apply any corrections we get. We also have a fixed base station. Once we get that process trajectory, we can use that to generate a more accurate point cloud, which we do through Phoenix's software, Spatial Explorer. Once we have the cloud, we'll bring that into TerraSolid Suite and use that to calibrate it to itself to really bring it home to that last little bit of accuracy, to really lock down as much as possible. After that, we have a number of macros that we'll run to find the bare earth and to strip out any vegetation, any buildings, anything that's not the ground. And from there, we'll generate a surface based off of certain model key points, which is, I'm sure you're familiar, like a form of kind of intelligent decimation to only key points on the features where you need and thin them out where you don't. After that will be one more look to go through and, we'll fill in points in detail where we need. Maybe that means adding points, maybe that means adding break lines. But ultimately, once you've got everything looking the way you want, you've picked up the features that you want, we will export the whole thing as a land XML file, which we only then bring into Civil 3D. And we'll bring that in along with an ortho photo and whatever metadata you need. And that's what actually goes to the engineer.
Gotcha. Yeah, that's so just to reiterate, like dialing in your ground classification macro, and then maybe you have 10 million ground points at that point, then using that intelligent decimation to just lock in the model key points where there are changes in elevation. So you can kind of weed out the points that are more or less redundant, right? Like on flat surfaces, planar features,
right.
And then get that 10 million points maybe down to something more usable, right? Like 10,000 or maybe 40,000 or something like that to build the land XML to then bring into probably Civil 3D, you said at that point?
Correct,
Mm-hmm.
correct.
Mm-hmm. Okay.
A huge part of what we do on the processing side is really about data management. You can kind of break down the whole processing aspect. Of the front end of that processing is trying to get as accurate of a model as you possibly can, and that's pretty much down to bare earth. But after you're calibrated and you have bare earth, and it's really about having a more manageable product, because if we delivered a surface that was just all the ground points, for your average user on any kind of computer, like it takes some serious horsepower to be able to handle all those points, and that's just not practical for a company of our size and how many engineers we have in different, because you never know who's going to be using your data. So from that point, it's as you say, it's all about pulling the information you actually need and isolating that, putting it in a concise, manageable, and easily understandable package.
Right. Well, Angela and David, thank you again for sharing all of your lessons learned and yeah, teaching us about how to utilize LiDAR in real world engineering and surveying applications.
Mhm.
At this point, I'd like to hand it over to Lido, and we'll begin the question and answer portion, and we'll get some of the panelists' questions answered.
Yes, a number of the questions that we had were already answered throughout your discussion, so there are a few left though. First one I'll ask is, what determines what altitude and speed you use for your flight planning? And what speeds do you typically fly at?
On the VUX, we typically fly at about 300 feet and at about 15 miles an hour, give or take. But that's something that is really subjective, depending on the site conditions, depending on what you're looking for. The more you have to penetrate, the more points on the ground you need, which is going to mean flying lower and slower. But 300 feet at about 15 miles an hour is a good kind of start point. That's our ballpark.
And do you use our Phoenix Flight Planner to help you start off and plan these flights? Since it does give you some point density calculations, or is it just that you know from experience what you need to fly at?
We do use it just to check the point density and make sure that it's what we need. But our flight software that we use in the field is called UGCS. Yeah, that's what we use to control the drone and plan it out.
I know UGCS has both subscription and persistent models that for enterprise and professional versions.
Yeah, and terrain modeling, and there's a lot you can do with it.
Here's another question. Is there any value to using check shots placed under the canopy?
Oh yeah, for sure.
Absolutely.
We want to know what our accuracy is across the site. Like I said, like under trees, thick grass, short grass, hard surfaces. We really don't have, in our area anyways, under the tree canopy tends to be the less vegetated because nothing grows under cedar trees. Unless there's, sometimes there's a lot of underbrush, but we have had no problem getting through trees in Central Texas anyways.
Okay, great. And what, I think you might have mentioned already, but what program do you typically use for extracting the line work for brake lines and planimetric? What do you use to generate those? Is that from one of the TerraSolid products, or is that from Topodot before you go to Civil 3D?
Yeah, we use both, mainly TerraScan, TerraModel, and then we do have Topodot that we use on some things. We're still getting used to those tools, but we've been using TerraScan for so long. That's just what we go with because we know it. So we've got that workflow down.
We've also found that Topodot is a terrific program with a lot of terrific tools, but we primarily use it for more for mobile data, or for if you're picking up road features specifically. That's where it really shines.
Assets and things like that.
Yeah.
And what kind of vertical accuracies are you seeing from the VUX UAV?
From the VUX, we're getting less than a tenth, typically 0.08, 800ths, which is excellent. Our other Velodyne, we're about 0.12, 0.16. So this, I feel like it's pretty much double the accuracy of the Velodyne.
And how is your is your workflow different going from multi-laser setup to the single laser setup?
Not really.
The overall workflow is the same. There's some stuff that changes, some minor tweaks in terms of, like, we have 2 different ground macros depending on what scanner you're using, but the overall workflow is the same.
Yeah.
Okay, and here's a very good question. This is actually one that I think we addressed pretty well in our training. Can you speak a bit as to flight planning as far as IMU calibration? Are you performing figure eights? Are you using box turns or bank turns at the end of flight lines? And any kind of heading alignment maneuvers mid-flight line that you use?
We've started using, we do a figure eight and a kinematic alignment at the start and end of each battery swap. This is probably, in my opinion, a little bit overkill, but it's been really nice to have that extra redundancy when you need it. You really don't want to have to go out and refly something because your IMU got a little out of whack or your GPS, you lost lock or something like that, just in this one area, this one time. So yeah, we do a kinematic and a figure eight at the front and end of each flight. And it's a really nice safety net to have when you're processing afterwards.
Absolutely.
And then at the end of each line, you do rounded turns.
Correct,
Yeah.
correct. Yeah, we make sure that
You're not banking too hard.
right, same rules really as mobile collection is try to keep everything always moving forward, and minimize any pauses or stoppages as much as you can in any hard jerky movements, and certainly never moving backwards.
And I do remember that back in I think the early part of 2000, you had actually rented one of our Regal systems from us. I imagine that was to evaluate the jump to your eventual purchase. How did obviously it went well. How did you? What were your initial impressions of going to a single line scanner or a Regal system, coming from the multi-line scanner when you did that pilot project?
I can tell you, as soon as we started scanning with the VUX, I did not want to go back to our other scanner just because the data was so much cleaner. Less noise is what I mean by that, and more precise. Again, not to say the Velodyne is not useful, because it is. It's been a great scanner. It still has its place, but just the data is much more pleasant to work with from the VUX. And you guys, I think we did we rented that system from you, and we were trained on how to use it in less than an hour. And we did a 30-mile long roadway project with it out in West Texas. Didn't have any problems. So that's really kind of what sealed the deal for us to purchase the one that we did.
Yeah, if I could just speak to that a little bit, the accuracy was phenomenal, but that was something that I had expected because we had seen those values on paper, before actually using it. The one thing that was a shock that really popped for me is the incredible intensity range of it. We've found that we've picked up intensities that we can't even pick up on with other scanners, be it if they're too low.
Mm-hmm.
And with this, they were so crisp and well put together. I mean, it was just like looking at a photo a lot of the time, particularly with mobile data sets. So, yeah.
Which does have its own challenges compared to flight also, yeah.
For sure.
Right.
Do you want to talk a little bit about your mobile setup?
Yeah, we have a Ladybug 5 camera integrated with our VUX. Again, in both scanners we have can be used with mobile. We have a dual antenna system from you guys. We've run it, we had projects where we will drive a roadway and also fly it. We have found if we fly low enough, 150 feet or so, we can get similar accuracies as you can mobile. But it does depend on the project and the requirements there. But sometimes, if they're just looking for edge of pavement, we can get that with a drone. Just depends, again, on the size of the project, where it is, things like that. But yeah, it's nice to have, and the Ladybug is nice to have too, is that street view level imagery and to help colorize a point cloud. You know, in case you missed something, you've got a picture of it, you know, to see, you know, what you collected.
Some extra validation.
Mm-hmm.
All right, I've got another question here. I am not a geomatics or a GIS guy, so I might butcher this, but let me try to read this. It's a vertical accuracy that was stated RMSEZ. I'm guessing that's the height against the calibration control, or is that NVA, VVA check shot values?
So it's against the check shot values. We, you know, calibrate to our ground control. We move. In TerraSolid, there are tools to do a control report where you measure against ground versus your panels or targets. We use the 10 that we create because that's what we're delivering, and we get that accuracy report against that. And then we will go through and kind of divide up the check shots, whether they were vegetated or non-vegetated. We try to, you know, use the ASPRS standards for a 1 foot contour. We're always way better than that. But we typically don't deliver anything, definitely not over 0.2 of a foot, but typically we're right at 1/10. So we have some wiggle, you know, vegetation, you can be a little less accurate, I guess. It just depends on the ground cover.
Okay, and I have another really interesting question here. What information do project engineers typically neglect to give you during the preliminary processes, and I guess during the business requirements development portion?
That's a great question.
Yeah.
Someone has experience, it sounds like. One of the big things is access. They'll tell us, you know, this one's ready to go, and you get out there and the gates are locked, or you've got a mad landowner and they don't know what you're doing. There may be cattle on the property and they've eaten your control panels before you can get out there. Or they will tell us, we learned the hard way and now we know what questions to ask before we even go, I guess, is, you know, what is this going to be used for? Is it just a flood study, or are you designing a roadway? Sometimes, you know, that can change things. So if it is a flood study, I'll say, well, maybe you need a little bit more outside of the project area to calculate your drainage into the site. So we'll pick that up. Yeah, we try to get as much information as we can in the beginning. We're very busy this time of year, and I will say that you have to really take a step back and not get in that auto mode of just pushing out projects. You gotta, you know, stop and think about what you're doing and who you're doing it for.
That is some great insight. All right. Thank you very much. I think that's the end of the questions. Corey, is there anything you want to sum up with?
I just want to say thank you to all the attendees for your time and attention today. And especially thank you, Angela and David, for your time and for all of your insights. I think this has been extremely informative. I know I've learned a lot. Yeah, thank you. And
thanks for having us.
Absolutely. And if anybody has any feedback, topic ideas, or questions, please submit them to info@phoenixlidar.com. And we look forward to seeing you at our next month's webinar. So have a great day, everyone. And thanks again.
Thanks, everybody.
All right, this concludes our July 2021 Phoenix Lidar Systems webinar. We will have a replay available for this on our website, phoenixlidar.com. Go to the news section, and you'll be able to find the link for it over there. Thank you very much, and we'll see you next time.